Welcome back. We're going to solve 4 more to finish up solving logarithmic equations. And actually, that'll also finish solving exponential and logarithmic equations. All right, so here we have another problem. Log x plus log x minus 9 equals 1. All right, and the good idea to write the steps that I have on the right-hand side there in your notes. All right, so we don't want to solve it with 2 logs. We want to condense that into a single log. So we're going to use the product rule. Right, because we see we have a sum of logs, and a sum of logs equals the product of a single log. So we can rewrite this as log x times x minus 9 equals 1. And now we only have 1 log. So now we need to simplify. Right? We've got to distribute the x to the x and the negative 9. Right, so we have now log, I'm going to use parentheses here to show we have more than one term. Right, so log x times x is going to be x squared. X times negative 9 is going to be negative 9x equals 1. Now we have log equals a number. Right, and anytime you have log equals a number, right, you're going to exponentiate. And all that means, it's a nice fancy way of saying write it in exponential form. Exponentiate. Right? So we're going to write as an exponential equation. And you can do that every time you have log equals a number. Right? So on one side, we're going to have x squared minus 9x. And that's going to be equal to base raised to the power. Right? So what's our base? If there's nothing there, our base is 10. Right? So anytime you have no base written, and it says log, not ln, which is natural log, that's always going to be 10. Right? So that's what my little, I've shaded in here. That's what that little circle is trying to tell you there. Anytime you don't see anything there, it's going to be 10 as your base. All right, so we have x squared minus 9x equals, our base is 10. And of course, this is the exponent, is the 1. Actually, let me label that as well. So this is your base, your result, and your exponent. Right? So base, which is 10, raised to a power, which is the first power, equals our result, equals x squared minus 9x. In other words, when you raise 10 to the first power, what do you get? You get x squared minus 9x, according to that equation. So 10 to the first power, that's just 10. So we have x squared minus 9x equals 10. And now we need to set it equal to 0 anytime we're solving an exponential equation, a quadratic equation. All right, so if we subtract 10 from both sides, we had x squared minus 9x minus 10 equals 0. So now we want to factor. All right, so now a times c, 1 times negative 10 is negative 10. We need 2 numbers that multiply to give us negative 10, but add to give us the b term of negative 9. And I hope you right away are thinking negative 10 and 1. That would multiply to give us negative 10, and negative 10 plus 1 would add to give us negative 9. All right, so we have x squared minus 10x plus x minus 10 equals 0. All right, and this is just a review from solving quadratics. First 2 are a group, second 2 are a group. All right, x squared minus 10x, let's factor out the x. If we divide both of those by x, we're left with x minus 10. And what are you going to factor out of x minus 10? Well, of course, just a 1. That's their greatest common factor. All right, so what you pulled out is one factor, x plus 1, and that repeating x minus 10 is the other. You can just factor that x minus 10 out, and that leaves you with the x plus 1. Last thing we have to, well, not the last thing, second to last thing, because we're going to have to check our solutions, but the last thing on this slide is going to be we need to solve for x. So we've got to set x plus 1 equal to 0 and x minus 10 equal to 0, and that's a pretty easy equation to solve, isn't it? All right, so just subtract 1 from both sides, x is negative 1. Add 10 to both sides, x is 10. So those are your 2 solutions. And then you got to check and see, are they both good solutions? Are neither of them good solutions? Is one a good solution, the other one not a good solution? All right, so let's check on the next page. X equals negative 1 and x equals 10. And I think I left myself space on this page. Let's find out. Yes, I did. All right, so let's check x equals 10 first, and then we'll check x equals -1. All right, so we plug in 10. We have log of 10 plus log of 10 minus 9, that goes in parentheses, is equal to 1. Let's simplify this. All right, well, what's log of 10? In other words, 10 to what power gives you 10, right? Because if there's nothing written, we know our base is 10. So we've got log base 10 of 10. Well, that's just 1. So this is equal to 1. Then we have plus log 1 equals 1. All right, well, now what do I have to raise 10 to get 1? Well, that's just 0, right? Anything to the 0 power is 1. So this is 1 plus 0 is 1. And that certainly checks out. All right, I'm going to just move these things over here, just as little reminders. And now let's check that second solution. Come on, there you go. Come on, equation. There it is. All right, let's check the second one. So log -1 plus log 10 minus -1 equals 1. Well, you could simplify minus a -1. That's going to be 11. Oops, did I just put in the wrong? Oops, I'm sorry. I plugged in the wrong number. I'm looking at where I plugged in the 10. I need to look up above there. So log negative, oops, and now I put the eraser in the wrong spot. Log -1 minus 9 equals 1. All right, so now let's simplify. I'm not going to do anything but simplify that. Plus log -10 equals 1. Now do not condense. What you need to do is stop, because we have a problem. One thing, where's the rest of my sentence? We have a problem. And the problem is this and this are not real numbers. So log -1 and log -10 are not real numbers. X equals -1 is an extraneous solution. Now don't always assume just because our answer is negative that it couldn't work out. It could if our equation was written a little different. Like for instance, if it had a -2 in there, well then -2 times -1, well that would give us positive numbers and that would have been fine. Right? So always check, right, no matter what your solution is, to make sure that you get a real answer. Oops. In this case, well, we'll just rewrite that again. In this case, x equals -1 does not work out. That is an extraneous equation, extraneous solution. I was thinking of the word solution, not what I wrote. That's what I was thinking. So that's an extraneous solution. All right, so this one is a good solution. X equals 10 is a good solution. This one here is an extraneous solution. And so make sure you don't say that's your solution, because that's an extraneous one, which means we did all the right work, but we got a false answer. All right, so one done. Let's do 3 more. And all of these we're going to use properties of logarithms to solve. Now I'm just going to stick to the product rule and the power rule. We'll look at the quotient rule a little later on in the year after we look at solving rational equations. So here we have another problem. Log base 2 of x plus 3 plus log base 2 of x minus 4 equals 4. Not a bad idea to write the steps that are on the right-hand side. Our very first step is to use the product rule, right? So the sum of logs becomes the product of a single log. So that means we've got log base 2 of x plus 3 times x minus 3. We don't need two log base 2's. We just need one when we condense that into a single product. Equals 4. We got to simplify, so we're going to multiply. Right, so we're going to have log base 2 of x times x. It's going to give us x squared. And then the outer terms, x. Here, I'll erase this one. So we did x times x. Now we need to multiply x times negative 3. It's going to give us a negative 3x. Now we need to multiply the inside terms. Oops, there we go. Oh, I lost my square there. 3 in the x, that gives us positive 3x. And then finally, we need to multiply the last terms. And I need to make my eraser smaller so I can stop erasing things I need. There we go. Minus 9, right? Because we have 3 times a negative 3 equals 4. So all we did was we FOILed, right? We multiplied x plus 3 times x minus 3. I'm going to write that nicer. Right, and we'll combine the like terms. Right, so we have log base 2 of x squared. Oops, sorry. When I copied this again, I copied that wrong. Excuse me, that's a minus 3x. Right, because that was an x times a negative 3. So we have x squared minus 3x and positive 3x. That's 0. So we're going to have x squared minus 9 equals 4. Step number 3, we need to exponentiate, right, because we have log equals a number. So we're going to rewrite that as our base raised to a power gives us a result. Right, so the base is 2. Right, so 2 raised to a power. Actually, I'm going to write that in. This is our base. This is the power. This is the exponent. So 2 to the 4th equals, and then we have x squared minus 9. This is the result. Right, now we need to simplify that and then set everything equal to 0. Right, so 2 to the 4th is going to be 16. So we have 16 equals x squared minus 9. Subtract 16 from both sides so we get everything on one side. And somehow I've changed from writing in green to writing in red, but I guess that's okay. 0 equals x squared minus 25. Now this one is a nice easy factor because this, switch back to green, is a difference of squares. So remember, when we factor a difference of squares, it's going to be square root plus the square root minus the square root. Right? Because x squared and 25 are both perfect squares, and we have a difference. There's a negative in there. All right, so square root of x squared is x, and then plus the square root of 25 is 5. And then again, square root of x squared is x, and square root of 25 is 5, but this time it's going to be a minus. Right? When we've got our constant there has a different sign, it's the same thing except for the sign. It's called the difference of squares because the middle drops out. Right? Because we would have a minus 5x and a plus 5x, and it would just drop out and give us x squared minus 25. All right, so now we just have to set that our two factors equal to 0 and check them out. So if x plus 5 equals 0, x is negative 5, and if x minus 5 is 0, x is 5. So let's check those two out. I'm going to need an extra page, and I don't think I left myself one. So let's see if I can. Actually, maybe I did leave myself one. Oops. Well, I'll move that. No. It just doesn't like to do this. Instead, it just wants to keep cloning. Bad computer. Actually, here, I'll get away from the smartboard. We'll get rid of all these. I know I've been entertaining you, making lots and lots of copies of the exact same thing when I was just trying to copy one. Let's get rid of this one, cut. And there we go. Now let's go to the next page and check our solutions, 5 and negative 5. And did I actually write the equation down? Any day now. Oh, I did write the equation down, so I didn't even have to copy it. All right, so let's check our two solutions. It was x equals 5 and x equals negative 5. So we have log base 2 of 5 plus 3 plus log base 2 of 5 minus 3 equals 4. That gives us log base 2 of 8 plus log base 2 of 2 equals 4. Well, what's log base 2 of 8? In other words, 2 to what power is 8? Why, that's 3. So this is just equal to 3 plus, what's log base 2 of 2? In other words, 2 to what power is 2? That's just 1 equals 4, and that checks out just fine because 4 does equal 4. Now let's check our other solution, which was x equals negative 5. Okay, and we have, and I'll give myself a space there. All right, so we have log base 2 of negative 5 plus 3 plus log base 2 of negative 5 minus 3 equals 4. And we know that if we have a log of any negative number, we are just going to stop immediately and know that this solution does not work out. So this one is a good solution. This one is an extraneous solution. And we're done with this one. All right, we wouldn't include that one as, we would just said that was our extraneous solution. But if they asked us what was our solution, then we would say 5. If we were asked what's the extraneous solution, we would say negative 5, because this is the one that didn't work out. All right, let's do another 2. And there we are. This was the last one in your notes, by the way. So we have log base 4 of x plus log base 4 of x plus 1 equals log base 4 of x minus 1 plus log base 4 of 6. And you might think, oh, this is so complicated. But it's really not. I see we have sums, so our first step is we need to use the product rule. Right? And we need to change a sum of logs into product of a single log. Right, so that makes this log base 4 x times x plus 1 equals log base 4 x minus 1 times 6. Oh, that just looks sick, doesn't it? Good enough. All right, so step number 2, simplify. Multiply those products. All right, so we distribute the x to both terms. We'll have x squared plus x, and you should use parentheses to show you're taking the log of that whole amount. Over here, we distribute the 6. We have log base 4 of 6x minus 6. All right, so this time we're not going to exponentiate because we have log equals log. All right, so you're going to set what follows equal to one another. So we're going to have x squared plus x equals 6x minus 6. Right? It's not log equals a number this time, it's just log equals log. So you can drop the logs, they're both log base 4, and because the only way log base 4 of x squared plus x is going to equal log base 4 of 6x minus 6 is if x squared plus x equals 6x minus 6. You need to set your equation equal to 0 because you've got a square term. Right? There's an x squared in there, right? Because we have to be able to factor. All right, so let's keep x squared positive, so we'll subtract 6x from both sides, and we'll add 6 to both sides. All right, so that's going to give us x squared. X minus 6x is a negative 5x plus 6, and that's just going to be 0 on this side. All right, so now we want to factor. 1 times 6 would give us 6. So we need two numbers that multiply to give us 6, but add to give us our b term of negative 5. All right, well, it's going to add to be a negative. They're going to have to both be negative. All right, and if we multiply them, we'll have a positive product. So negative 2 times negative 3 equals positive 6, and negative 2 plus negative 3 does equal negative 5. All right, so we'll replace that negative 5x with a negative 2x and a negative 3x. And then, of course, as always, the first two are a group, the second two are a group. We'll factor out an x. We have an x minus 2. Factor out a negative 3, and we have an x minus 2. So we can factor out that repeating x minus 2. That's one factor. And the leftovers, x minus 3, is the other factor. We'll just set those both equal to 0. I need to write smaller. So we have x minus 2 equals 0. X is 2. X minus 3 equals 0. X is 3. There's our two solutions. We do have to check them both to make sure that, to see if either works, both works, none works. This time I do not think I wrote the equation on the next page, but let's see if I did or not. And the answer is nope. The next problem's on the next page. Let's see if it can manage. Actually, I will move away from the smartboard, step away from the smartboard, and copy and add a page. And any day now. I think I need to make a song. Waiting for the smartboard song. Okay. Our two answers were 2 and 3. Let's check them both out. So we have log base 4 of 2 plus log base 4 of 2 plus 1 equals log base 4 of 2 minus 1 times log base 4 of 6. All right, so we have log base 4 of 2 plus log base 4 of 3 equals log base 4 of 1. Oops, we lost a plus. Plus log base 4 of 6. Right? And some of these are actually, we could evaluate, like log base 4 of 2. That'd be 1/2, right? Because the square root of 4 is 2. And as an exponent, the square root is 1/2. And well, anything to the 0 power is 1, so log base 4 of 1 is just 0. But log base 4 of 3 and log base 4 of 6 aren't that pretty. So far so good though. Everybody is positive, right? Positive, 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 positive. So we don't have any non-real numbers here. By the way, they wouldn't be called imaginary. They would literally be a non-real number. Square root of a negative, that's an imaginary number. Log of a negative, that's just nothing. All right, so since everybody's still a real number, let's condense. All right, so log base 4 of 2 plus log base 4 of 3, that's log base 4 of 2 times 3. Log base 4 of 1 plus log base 4 of 6 is log base 4 of 1 times 6. And log base 4 of 6 does indeed equal log base 4 of 6. And you can check that that is a real number. And so that works out. So this one's a good solution. We'll give him an exclamation point and a smiley face. Let's check out the other one. X equals 3. Actually, I'm going to switch colors. It's going to be lots of blue up here. and see if this one works. All right, so we have log base 4 of 3 plus log base 4 of 3 plus 1 equals log base 4 of 3 minus 1 plus log base 4 of 6. That doesn't change. All right, so now let's simplify this a little bit. Log base 4 of 3, log base 4 of 4, that would just be 1. But log base 4 of 3 is not so pretty. Log base 4 of 2, that would be 1/2. But log base 4 of 6 isn't so pretty. So again, everybody's still positive. Positive, positive, positive. So we're still dealing with real numbers. Let's condense. So we have log base 4 of 3 times 4 equals log base 4 of 2 times 6. And log base 4 of 12 does equal log base 4 of 12. And that's a real number. It's an irrational number, but it's a real number. And so that one checks out perfectly fine. All right, so we've got two solutions here. So it is possible to have two solutions. And here is an example of one that has two solutions. I think the last problem that we're going to do isn't in your notes, but you could add it. And this one involves the power rule. We haven't done one with a power rule, I don't believe. So let's do one now. Maybe we did one earlier. But let's do one anyway. So I don't remember doing one on the earlier podcast. All right, so we have 2 times log base 4 of 2x minus 9 equals 5. There's an easy way to do this and a hard way to do this. This is the hard way, so don't do it. The hard way would be to make that 2x minus 9 squared. You'd have to FOIL that out. You'd have a quadratic to solve. You'd have to rewrite it as an exponential. Instead, isolate the log expression. Right? That's the easy way. Right? So if this were up here, I would have moved it to over here purposely so that we could divide both sides by 2. Because that would be a lot nicer. It's a lot nicer working with it as a coefficient than it is an exponent. We have a lot less work to do. So we'll have log base 4 of 2x minus 9, because these two would cancel, equals 5/2. Now we have log equals a number. So we're going to exponentiate. We're going to rewrite as an exponential equation. 4 is the base. Oops, I almost dropped my pen there. 4 is the base. 5/2 is the exponent. And this is the result. All right, so we have 4 to the 5/2 power equals 2x minus 9. If you have a fraction as an exponent, write it in radical form. All right, the numerator is the power. The denominator is the root. All right, so this is just kind of going back to solving radical equations. All right, so we're going to rewrite that as the square root. We could put the 2 here, but we don't need to. It's understood that if there's no index, we want square root. And we're going to raise that to the 5th power, equals 2x minus 9. Now it's just a simple evaluate and solve. Square root of 4 is 2. 2 to the 5th is 32. Add 9 to both sides because we're going to solve for x. Is 41 equals 2x. And then divide both sides by 2. X is 41/2 is fine. If you want, you can make it 20.5. It's a terminating decimal, but 41/2 is just fine. All right. And we shouldn't get a false solution here because when we rewrote it, we were raising something to a power. We should only get positive numbers when we raise to a power. But let's check it out anyway. What the heck? Let's check one of these out. We don't normally check out the where we exponentiate, but we'll check it out anyway. All right, so we have 2 log base 4 of 2 times 41/2 minus 9 equals 5. It'd be good to show you this one would work out. Right? And so we have 2 times log base 4. The 2's will cancel here. That's going to give us 41 minus 9 equals 5. 41 minus 9 is going to be, that's an odd, I don't see anything. It's a strange looking number. It's going to be, oh no, it's going to be 36. Yeah, wait. Oh man, I must be really, really tired. 41, 32. Let's try that again. Log base 4 of 32. So, not off the bat, not a really simple one to simplify because 4 doesn't immediately, you can't, off the top of your head, you usually don't think of 4 to what power is 32. But, right, we could figure this one out. We have one of two choices. Right? We have the 2 here. Choice number 1 is to move it back as an exponent and have 32 squared. Choice number 2 is divide both sides by 2. Let's just divide both sides by 2. And actually, we should expect that we're not going to have a really nice looking number because we have 5 halves, but it'll still solve out pretty nicely. So now we have log base 4 of 32 equals 5 halves, and we know that's true, right? Because, oops, what happened to my 2? That's actually what we got when we solved. But let's continue this anyhow. All right, so if we want to evaluate, we just think, hey, does that work out? Hey, so does 4 to the 5 halves equal 32? In other words, does the square root of 4 to the 5th power equal 32? Well, the square root of 4 is 2, and 2 to the 5th power is indeed 32. And that looks like 25, but that is 2 to the 5th power. My exponent's too big. All right, so you can see that checks out. Now, you don't have to check these ones where you're exponentiating because you're raising a positive number to a power. You're going to get a positive number. You should not get any extraneous solutions. But here, this just shows you that that did indeed check out. By the way, if you moved it back up, you would have, so if I move this back up, I'd have log base 4 of 32 squared equals 5. And if you square 32, 4 to the 5th power should be whatever that's equal to. But anyway, here's what it looks like to check. I'm just going to write down that this was an optional check and that you didn't have to do that one. All right, and that's the end of my podcast. If you have any questions, as always, just ask me in class. I'd be happy to go over any more or over any of these problems or solve a few more. Thanks for watching. This is the end of solving exponential and log equations. Thanks for watching. Bye for now.